Alright, welcome back. If you're following this tutorial and you're in the US, I hope you had a good Thanksgiving holiday. If you're sometime in the future, I hope whatever time went between the last video and this one went pretty well for you. Let's just kind of pick up where we left off. So we've got our little shooter character here. If I hit play, I can use the mouse as almost like a virtual joystick, and then the player is also clamped to go no farther to the left and no farther to the right than the screen, and same thing with up and down. So now, today, we're going to create the fire that the ship actually will do. And just like the actual PixelCraft space shooter, we're going to have our ship be firing just kind of automatically all the time. So I'm going to grab my pixel art for the ship that I just made. I'm going to set this to the same number of pixels per unit as I set my ship, which is 32. I'm going to make sure also, when I do this, that I change it from bilinear to point, no filter. If you're making something with a pixel art and you want it to have nice clean edges, you want to make sure that you're using a point filter, which is no filter. I'm going to pull this into my scene here. Oh, that is pretty big in comparison with the ship. Huh. Alright, well, let's change its pixel ratio here. So, I wonder what it's reading. Yeah, it's reading it as 32 by 32. I swear I changed it. Okay, well, we'll just change this to 64, which will cut it in half. There we go. It's better. I might even want that a little bit smaller, but that's fine. So I pulled it into the scene, which creates an empty game object with a sprite render. I'm going to change the name of this. I'm going to call it, we'll call it regular fire. I'm also going to go into the sprite renderer and change the color. For the starting color, I'm going to go with something kind of yellowy. Nobody likes yellow, so people will want to upgrade from that right away. I'm going to add a few components to this. In Physics 2D, I'm going to add a rigid body 2D. Unity likes things that move to have a rigid body, even if you don't end up using most of the rigid body physics. I'm going to set, I don't mean to set its mass. I'm going to set its gravity scale to 0. And this is something that I want to have continuous collision detecting, because these are probably going to be moving pretty fast, and I want them to always know where they are. I'm going to also freeze the z-axis on this. And anything else in here I need to change? No, not at the moment. So there's my rigid body. The next thing I'm going to add is a collider. I'm going to Physics 2D. I'm going to use a box collider. If you zoom in, you can see this box is too big. You want to be generous to the player, but not quite that generous. So I'm going to scale down the X and scale down the Y just a little bit. Let's make this a nice, neat number, 0.25. And make this, say, 0.4 is too small. Let's do 0.45. Yeah. If you zoom in really close here, you can see where that collider box is. It's this green line right here. And I want it to be, you know, a little good for the player, but also have it require a bit of skill. Alright, over here I'm going to make sure that I check mark this is trigger button on the box collider, because I want, when this overlaps with enemies, for it to trigger something, specifically taking health away from the enemies. Okay, yeah, I'm going to add this to my prefabs. So I don't have a prefabs folder in here yet, so I'm going to go to my assets, right click, create. I'm going to create a folder. I'm going to call this prefabs, and I'll drag this ship regular fire right into there. And you can tell when something becomes a prefab, because in the hierarchy here, its name is going to turn blue. So I can just delete this. Now I'm going to create a new script, and I have a script for player movement. I'm not going to keep that just player movement. I'm going to make the fire script something separate. So I'm going to create a new C# script, and I'm going to call this player fire controller, and I'll attach that to my player object, and then I'll open that script up. Oop. Did it attach? No. There we go. Alright, so I'll open this up in MonoDevelop. Now, there's a few things I'm going to want to do. So I want the player to feel fairly empowered when they begin, so that they can feel even more empowered as the game goes on. So as this loads up here, we can take a look. We want to start with triple fire. That way, every other power-up we come up with is going to seem like it's that much cooler than triple fire. Alright, so let's embiggen this script so everybody can see what's going on. Up here in the top, I'm going to make a few global variables. First thing I'm going to make is a reference to a position in space that I want the fire to appear at. So I'm going to call this a public, and positions in Unity are transforms. Transform, and it's the point where we're firing from, so I'm going to call it fire point. Next, I want to reference the laser itself that we're creating, and I'll call this public game object because we're referencing an actual object in the scene. And this is going to be, let's say, regular fire, because I want to be able to do upgrades and stuff. Also, I'm going to need to have a counter ticking down, because we don't want the player to have to push a button to fire. We want to just automatically fire every fraction of a second or so. So I'm going to make a public float, and I'll call this fire weight. If I spelled it correctly, that would be good. And then I'm going to create a private one to go with that. Private float. Fire weight. Jeez. Seconds. So also, just to keep my code nice and neat, I'll make a header up here. So we'll call this header, in quotations, variables. Okay, cool. So just kind of explain what's going on here with these two variables, fire weight and fire weight seconds. So fire weight is how much time you want to go in between when the first one fires and the next one fires in seconds. It needs to be a float because it's going to be a decimal value, 0.1, 0.2, 0.5. And then fire weight seconds is going to be something that's ticking down in the background that is going to need to reset to the value that you set up here. So the first thing I'm going to do is set that fire weight seconds to be equal to fire weight. So we'll do fire weight, seconds is equal to fire weight. Okay, so this is going to set that private variable, the one that we can't change in the editor, to be equal to the public variable. Now if I go down here in the update method, I'm going to, every time update is called, I'm going to decrement the fire weight seconds just a little bit by however much time passed since the previous frame. In most games that'll be a 30th to a 60th of a second, some games even less. So we'll say fire weight seconds, and I could just, if it were an integer, I could just count it down, but then you're not taking into account frame rate differences. So I'm going to say minus equals time dot delta time, which is how much time passed between that frame and the previous frame. So usually a 30th or a 60th of a second. So if our fire weight time is 0.1, then we're taking 1/30th of a second away from that, and then that'll be the new time, and then a 30th of a second away from that. And then we want to check if the fire weight seconds is less than or equal to 0. Fire weight seconds is less than or equal to 0. And in here, we're going to do something. So fire 3 lasers. I don't know why I capitalized 3. So this code for firing 3 lasers, there's a few different ways we can do it. And for now, we're going to do it the not so memory efficient way. Later on, I'll do a video on object pooling and show you how to use object pooling to do this, which is going to be much more CPU friendly. So I could call this in a separate method, and object-oriented programming says that you probably should, so we might as well. So down here, I'm going to do a public void, and I'm making it public because I might want to call it somewhere else. And I'll call this fire, open close parentheses, because we don't need to pass in any values. And then what I'm going to do in this method is I'm going to instantiate. And if you take a look here, at Unity's code, instantiate requires 3 variables to be passed in. The object that you want to create, the place you want to create it, and the rotation you want it to have. So I'm going to instantiate the object that we're referring to right here, regular fire. I want to instantiate it at this position, the fire point, wherever on the ship we want it to be created. Fire point. And for now, I'm going to say the rotation is just its regular rotation, which is quaternion dot Euler. Or sorry, not Euler, identity. Quaternions are a way for you to measure rotation in 3-dimensional space, rather than just thinking about rotation on 2 axes, the XY axis, or you can use a protractor. If you're thinking about rotation in 3 dimensions, quaternions can actually be a good way to do that. And I have a couple of mistakes here I'm going to fix. First, I didn't close my parenthesis, which is why I'm getting a little red line down there. And second, if I just say fire point, that's the transform, and in Unity, transform refers to the position, the rotation, and the scale. So Unity doesn't know if I want to refer to position, rotation, or scale of that object. So I'm going to go back into Visual Studio and make this fire point dot position, and then that red line should go away. All right, we're going to call this fire method. So in our update method, we're decrementing or counting down the fire wait seconds. If they're less than or equal to 0, then we're going to fire. And the reason it's good to do object-oriented programming is now if I have an issue, I don't have all this code kind of in here. I'm calling a separate method that I can debug on its own. So it's just a little cleaner. And then I'm going to reset the wait time to the previous wait time. So fire wait seconds. This is why we needed to have those 2 variables equals fire wait. Because if I just had the 1 variable that was decrementing, I wouldn't be able to reset it to its previous value. Okay, save this script and pop into Unity. Now, if I click on my player, I'm going to see a few things show up here. First of all, if you'll notice, I have fire variables in this nice, neat, bold font because I used the header. If I get back in here, it needs to know a position, what I'm firing, and a wait time. For now, I'm going to set the wait time to be 0.3. And for the object, I'm going to go into prefabs, grab this regular fire, put it right there. Oop. Maybe. Oh, it's already there. Okay, cool. Now, for the fire point, I'm going to create this by creating a new object on the ship. So with the player highlighted, I'm going to go to create and create empty. I should have done create empty child, but whoops. So I created an empty game object. If you just create an empty game object, it's not attached to the player. I'm going to parent it to the player, meaning I'm going to make the parent, or the player its parent, and whatever affects the player affects this, by just dragging it onto the player like that. And now I've got this kind of window shade thing going on. I'm going to make this fire point visible by selecting this multicolored cube, and I'm just going to choose something appropriate for a fire point, like that nice red dot. Over here, I'm going to use the move tool. I'm going to move it to where I want my ship's fire point to be, and then I'm just going to nudge it in the actual inspector. Say the x-axis is 0, the y-axis is 0.6, and the z-axis is 0. Okay, and I'll rename this to fire point. Now if I go back to my player, it needs that transform position, and I will just put it right there. Now let's take a look at what happens if we just hit play right now, because I think it's kind of cool. You may or may not. Alright, so we're creating all of these little lasers. The lasers themselves aren't doing anything. So let's make a script to actually make the lasers do something. So I'm going to go to my scripts folder, right click, create a new C# script. I'm going to call this one laser controller. All right, and find my laser prefab. So once my computer catches up to me, go to my prefabs, my ship regular fire, and then I'm just going to drag my laser controller onto it. And then I'll open this script up in Virtual Studio, or Visual Studio, sorry. Okay, so I'm going to make some global variables here. First, I'm going to make some movement variables. So header, movement variables. And the first one is going to be the speed. We'll make this a float. Let's say public float speed is equal to, I'll just set it in the editor. I want to make a reference to its ability to move. So public rigid body 2D. Yeah, public rigid body 2D. I'm going to call this my rigid body. And yeah, down here in the start method. So this is what's called a reference. Actually, I'm not going to make this public. Sorry. The reason I don't want this to be public is if it's public, then I have to set it in the editor, and if I forget to do that, it'll be a problem. So I'm going to change this to private instead, and I'm just going to set it in code here really quickly. So this is a reference to the ship's ability to move. It creates like an empty container, but I can't do anything with what's in that container unless I fill that container with the rigid body in the scene. And to fill that container, I'm going to go down here to the start method, and I'm going to say my rigid body is equal to. Now, if you use get component, you're looking for the component of that type on this same object. If you use find object of type, you're looking for an object in the scene that has it. I'm going to use get component because we already added the rigid body to it. And in pointy braces, we're going to do rigid body 2D, open close parentheses, and then a semicolon. So this fills in that empty container of the player's rigid body. Now, also, in the start method, I'm going to say that my velocity, so my rigid body dot velocity is equal to. So now the velocity is going to have, if it's in 3 dimensions, it'll have 3 parameters, an x parameter, a y parameter, and a z parameter. We're dealing with a 2D game here, so we're going to say that our velocity is a new vector 2 because we're using 2 coordinates. And this needs to have an x amount that is traveling and a y amount that is traveling. For simplicity's sake, I'm going to start out just saying that the x amount is 0, but we'll come back to that. And the y amount is just going to be speed. And there we go. So if I pop back in here, oops, gotta save my script first. If I pop back in here, I'm going to wait for this to compile. There we go. I'm going to hit play. And then you'll see kind of what happens here. Oop, I didn't set my speed. So if I go to my prefabs, my ship regular fire, I'm going to set my speed to like 4, something relatively slow to start, and hit play. So let's check this out now. There we go. So there's a problem here. We're creating something called a memory leak over here, and we'll get to that next time. But for now, let's finish this off, and actually, it's still a really wide fire. Okay, for now, let's finish this off, and let's make it so that it's firing in 3 directions at once. So what I want to do is in Visual Studio, in my fire controller, let's close these off because they're from previous things. In my fire controller, I want to instantiate not just that one, but I'm going to instantiate, did I misspell that? I did. Instantiate regular fire at fire point dot position. And then I want it to be facing a different direction. Okay, and then for this one, I'm going to set its rotation to be quaternion dot Euler, and then I have to pass in an x, y, and z value. I'm going to say 0 rotation on x, 0 rotation on y, and then 45 rotation on z. And then I'm going to create another one. So I'm just going to take this whole thing here, I'm going to copy and paste that down here. And instead of using 45 on z, I'm going to use 135. Okay, save my script, pop back into Unity. Still isn't quite right, but we'll fix this. Okay, cool. So let's hit play. Okay, let me pause this so you can see exactly what's going on here and why this isn't quite right. So if we zoom in here, I've got this object, and this object. So they're being created in the right pattern, where one is halfway up and to the left, one is halfway up and to the right, and one's straight down the middle. But they're all going straight forward, and the reason why is because they all have the same velocity. So I'm going to go in here, going to leave this for just a second, we're going to come back to that, and I'm going to go to my laser controller. I'm going to just kind of, let's say here, I'm going to add a new variable up here. I'm going to make this public so that I can change it from other scripts and from the editor. So let's do public string. Nah, let's not use a string. Let's just use an integer. Public integer, I don't know. It's which one of these is left or right. So placement. And then in here, I'm going to create a switch statement. So what a switch statement is it's just like an if statement with a bunch of different conditions. What I want to do is I want to see what the placement is. I'm going to set the placement when I create it, and then using that placement, choose a vector for it, for its velocity. So we'll do switch placement, and then, and again, Visual Studio thinks that I'm just creating this now, like I planned ahead or something. Crazy Visual Studio. Okay, so we're going to have a couple different cases here. So we'll do case 0. It does all of this stuff, and then we'll break it. Then we'll have a, I hate how Unity does this, like, why does it need me to do it? And anyway, case 1, let's see, jeez. Gosh, this is so stupid. Okay, so case 1, my rigid body dot velocity is equal to new vector 2, and I'm going to set this one to speed, although that causes a math problem that I will explain next time. And then we'll break from here. Whenever you have a switch statement, you always have to have a break in each of the cases, otherwise it freaks out. And let's do case 2. My rigid body dot velocity equals new vector 2. And then this one is going to be on the negative x-axis, so we'll say negative speed. Okay, and then we need to break. And it's good defensive programming if you add a default case whenever you make a switch statement. And the default case here just breaks out of the loop, from that loop, out of the conditional. Okay, so now I'm going to save this. If I jump back in here, I'm going to have to zoom out a little bit here so you guys can see all the code. So I'm just going to zoom out, maybe a little bit less. There we go. So I'm going to call this one game object. Actually, yeah, game object. Center fire equals instantiate, and then, so what I'm doing is rather than just instantiating this, I'm instantiating it as a game object. And that means I can change some values here. And at the end, I'm just going to add a trailing as game object. Now, because I did that, I'm just going to make my little bit of space here. Because I did that, I can now say centerFire dot placement. Oh, I have to actually get the centerFire dot get component, and I want to get the laser controller from it. Dot placement is equal to 0. Okay, this looks complicated, I know, just bear with me. So what I'm doing is, rather than just creating this game object, I'm creating it as a named object, centerFire, and then I'm going to look for the laser controller component on that, and I'm going to set the placement value to 0, because 0 is this one right here, where it's just going straight forward. Now, I'm going to do something similar for the next one down here. So I'm going to grab this whole line, copy it and paste it. It's going to give me some errors, or some red lines right away. Maybe it won't. No, it won't. Okay, cool. So I'm going to space these out a little bit so it's easier to read. So the second one, I'm going to say game object, and the one that's 45 degrees is going to be the right fire. So game object right fire equals, and I want to instantiate it as a game object. Okay, and then I want to, instead of this being center fire, this is right fire, and this placement is 1, which means it's going to the right, because it's got positive speed on both the x and y axis. And then the next one, we're going to do game object, we'll call this one left fire, equals instantiate, and we're going to instantiate this as a game object. Okay, and almost done. So this is right fire now. Or sorry, not right fire, left fire. So left fire, and this one has a placement of 2. Okay, I'm going to save my script here, pop back into Unity, let this compile, and then let's see if it works or not. Didn't actually test this one ahead of time, so we'll see. Alright. Looks like I got my rotations messed up, but they're being created. So let's fix those rotation issues here. Actually, I don't need to fix any rotation issues. I just need to change these placements. Make this 2, and make this 1. If I save that, I will pop back in here. It's compiling. And there we go. If I hit play, there we go. We still have a couple issues here. First, we have a memory leak, which we'll fix next time. Second, we have a problem with the way that things are firing. If you notice, let me just pause this really quickly here. You can see it. Let me zoom in. So it's the first level, it's not too bad. Second level, third level, fourth level, it should be making this like arc, but it's not. In fact, the farther away from the main spaceship it goes, the more it's easier to see that it's not making this spread arc that it's supposed to. It's instead making these triangles. And there's a way that we can fix that, but we'll go over that next time. All right, thank you very much. Feel free to leave any questions or comments below. If you learned anything today, feel free to give me a like. Other than that, have a great day.